Let's now look at the stereochemistry of electrophilic additions. Now, some reactions, such as the one that I'm going to draw, do not generate a new chiral center. And so the stereochemistry is not important in those cases. So you'll have to pay attention to when a new stereocenter is made and when we don't have any new ones. Now, in this case, I know I'm drawing the hydrogen that we made, but this carbon right here is now the same as the one up there and all the way around the ring. So in this particular case, there's no new chiral center. Let's look at one where the stereochemistry actually comes into play now. So this is still a symmetrical molecule and it's flat, right? We've got sp2 carbons all the way around. And so there's nothing really to differentiate which side this will get attacked from. And so, as you may guess, in the case that we have no differentiation between the two sides, we will end up with a racemic mixture. So I'll just draw the two products that we make. And since this is symmetrical on both sides, it will not matter which carbon we add the bromine to. So in both cases, I'm just going to add it to this carbon right here. So we'll have this one, and then of course the corresponding one where this is solid. And again, because there's nothing differentiating these two, we will get a racemic mixture, or an equal amount of these two isomers. All right, now this is one where we really only generated one new chiral center, but it is possible to have some where we'll generate two chiral centers during the reaction. So I'm going to draw an example of that. Now this is very similar to our cyclohexene that we started off with, but now we're going to put some substitutions on, some methyl groups. I'm not going to draw all of the particular isomers. I suppose I could, actually. Might as well. But we're generating a chiral center here and also there. So we're making two new chiral centers. So there's quite a few isomers available. There should be 4 different isomers. Let's see here. say now we need to switch these two. So we'll have the hydrogen and the bromine in a different spot. So there's that one. I think that's all of them. May have drawn the same isomer in a couple of cases here. I'll have to check on that. Now, suffice it to say though, we can get quite a few products. Now, it is possible to have one of these favored over the others, and I've read that the trans product is favored when we have some solvent interactions with it. And so this is not necessarily going to generate a receiving mixture in every case.